Ikole ngambulo luku. With whatever we do. Jioni safu nola. With whatever we do. Hale yidemu new school. Nyepamne ne kudlukula. Nyepangiragala gena. Nyepamne ne kudlukula. Ibuloke no moto ni beti sola. Ibuloke ndato ni betoto.
Bigi Congo.
Lamin.
Na?
Lamin te jibe norin te nyame Lamin.
Kama na wulo kono.
Wulo kono nyinte mo Lamin.
Pabilenki.
Muna ngata afamole.
Haina.
Ngata. Ngoto le. Fabrama.
Mingi. Baba nyole.
Ngoto le Fabrama.
Namu jumala kan kuma ni ten.
Fabrama.
Jumala mu.
Ndele bare muso.
Lunda mana.
Kamo kata.
Jamani mbere.
Alindo ko.
Jamani.
Bari ngoto man kontande.
Bari jamani fana na ramu man kontan.
Ngoto minaka ngalamin je fom filitala. Lamin jibe nori nyala.
Lamin ida sira sama na benki. Yala so tol sayni no ko mo lokku momo.
Ngoto.
Nam.
Iterinte yalo ne Lamin hakilo diata bake karamu ngoto. Anu santeng ministry ko di ngole si suwo ko amanke ko do holiday
si bitun
bagona ringa
ala ni ko de namo balo
ala ni na ko na karta bulo be dam ala ni je
ngoto
nam
ngoto mon kontan feren
jamani mu nekata
ifika Lamin ki wulo ko no nyintay mon ko do fete malo Lamin nyande sila la be la moy kala karango
jamani karamol be soron ne ko fasita wulo ko nako
karamol ma soron ni ko karamol soron da amanke comme holiday lem ngoto dini ngo nyanta sila la ala karango la moy yamen kamen fue man kontan andamande
alla nyin kombo courant adanda la kombo len do la jankara mol soron do kamen courant ma do la kombo e ko ndol fana na kara mol soron je kara mol soron Lamin adara lo nyino la amanta ra fe na sokon ala mu nekela
Lamin ite foyte malon ko lesinol be ke kar radio to
nga fine
e ko nyina di mo Lamin ya mu na fonye
bir kabin mina kan tambita nteri maning Fatou tambite la sukol ala dinngol bebe siri be la moy ka
Fatou danso am fana tambita jele ni subala la ngaje dinngol be jet talanta nen kili warol e be seri jelet
sa Lamin fadante ku kili wo ke no la ba Lamin bita ka wulo ko no nyin taymo Lamin
amandara fennela
ite dine ko ni man si yakari lesino la moy radio to e balon nan
mu ne ka ke afonje ba ñaara ni alon
telentel jikot
afonje ba mu ne be ke
ite balon tel be jikritel ni man karambe ku kele yaaje nata karana mbasa malaya ay tarije
par ñarande kombo courant ho findira kombo ite nara yede ni sonka bay ko Lamin ma ñata la wulo ko aru karam mo be so da fanya membe kala
ko to wole nati ba ngal ne ni Lamin kuntal kombo courant o ka fa me kombo courant asototal wala kinay ko e si suwo kono bari ni ko e si suwo kono ibe karangol dike la radio lin telel to hani tele masoto to nyaay man tele soto da bungo bar radio be bulen koto batiri sanga ay si ay alamo
sa do kala nyaadi
ko ta ro bulaji
abe ko kala nyaadi
kamun ke nyaadi
radio abe wala moy la ibe mona falaje
ibe la karandirol kala jele
ti talle be radio ko men ga karandi
ila subject ro baby jele baby jele
wala nan ka coco moy fa dan so wolya ngombe tambi kana ngadi ningol je be ikadum bungo ko kala maro mo
asototal de
Lamin mala be karawala de
bari
laftalal ideal on ko inde every year second wala fourth
muna ni ko nde ko folle sini lamba nde le sini lo ne ba
say mba foke en koto wole fango yen wulindi yalo famo keta bat ñu fanam bulata ko ko don me yen nati jambi Lamin nyanta karana ntel be jiko be nyineka ya bulay kara wulo kono ta kilar ya bambalo yo be bulaje koto dinni ngoy si ayala le sino la moy radio
wara ka munda kara mo man soro Lamin nyanta kara si suka
regular la silale ayala le sino
dal ko korna kosmolon
kilar ya
ma be ngala ko momo sa en bido ni ko no kera
mengi bruso
ndebe ko do la da ba rosa no radio ba no bari woro radio ni abe jele ba ngamra do man nembe buljan dala nyara ni arbo ko fendi mo la Lamin tayra ba rosa
bara te ku folo ajibe nori nya Lamin tamete ku
teku
bari ko do famo ke
imagine nani nyambol si zol le keje kisiki man si zol no le kafun ka nyoma bari nyambu kino ni manya na kafindi ni nambe ko zol la ga
ngale limbeta de be nyambo do dilanna
nyara ni ko rim fennat nyara nata
bari famo ke da
ngata bungono Tami bungono nyara ngando ko fele ko ke baru nganda ni pelo la ndija
iyo awe better la
bungono bismillah bisu diara
ye fongo tanka sina dolu tanka koro ta koro
Hello viewers and listeners, welcome to another mathematics lesson for the lower basic category. And this lesson is intended for students in grade 4, 5, and 6. In our today's lesson, we'll look at addition of fractions with unlike denominators. But before we start, let's have a recap of our previous lesson on adding fractions with common denominator. So here we have two questions. Question 1 reads 3/9 plus 4/9. I'll take that again. 3/9 plus 4/9. So we have two fractions, and we are to add the two fractions together. And if you observe denominators of the two fractions, you realize that it is the same. You have 9 in both fractions. So already we know from our previous lesson that if you are adding fractions of a similar denominator, that is if the denominators are common, what do? You add the numerators and you maintain one denominator. So here in question 1, if we add 3/9 to 4/9, going by the rule, we are going to have 3 plus 4 will give us 7 over, since our denominators are the same, so we just maintain 1, and that is 9. So when we add 3/9 to 4/9, the result is 7/9. We move on to question 2. Question 2 reads 6/11 plus 2/11 plus 1/11. I'll take that again. 6/11 plus 2/11 plus 1/11. What can we observe from these fractions? We can observe that we have 3 fractions, and in all the 3 fractions, we have what? A common what? Denominator. So in each fraction, we have 11 as the denominator. Again, going by the rule, it says if you are adding fractions with a common denominator, what do you do to the numerators? You add the numerators and you maintain one denominator. And that's exactly what we are going to do here. So this will be equals to 6 plus 2, that will give us 8. 8 plus 1 will give us 9. So we'll have 9 all over. Since the denominators are the same, what do? We just maintain 1, and that is 11. So we'll have 11. So when we add 6/11 plus 2/11 plus 1/11, the result, that's the answer, is 9/11. So this is just a recap of what we have been doing in our previous lesson. We now move on to in our today's lesson proper. Okay, it says adding with unlike denominators. Adding with unlike denominators. It says to add fractions with unlike denominators, rewrite the fractions as equivalent fractions with a common denominator. Then add the fractions. Make sure your answer is in its simplest form. Okay? I would like to take that again. Adding unlike denominator, fraction with unlike denominators, it is saying that to add fractions with unlike denominators, rewrite the fractions as equivalent fractions with a common denominator, then add the fractions. Make sure your answer is in its simplest form. Okay, this is a rule, and if you can recall from our previous lesson where we are adding fractions with a common denominator, we were told that since the denominators are the same, what we need to do is just to add the numerators. But this time around, we have another thing, which is what? We are to add fractions with unlike denominators. So in that case, it is telling us if we are to do that, we first need to rewrite the fractions into what? Equivalent fractions. But with what? Something that is very, very important. It has to be what? With a common denominator. This is very, very important. Okay? Once we are able to do that, the next stage now is to add the fractions using the previous rule, since we'll have a common what? Denominator. Okay. How are we going to do that? We have, in the first fraction, we have 4 over 9 plus 5 over 8. And since we want to rewrite it as an equivalent fraction with the goal of having a common denominator, it is going to be, what are we going to do? We will take the denominator of the second fraction and multiply it by both the numerator and the denominator of the first fraction. In the second fraction, what are we going to do? We are going to make sure that we will take the denominator of the first fraction and multiply it by the numerator and the denominator of the second fraction. Now, I would like to take that again. In order to rewrite these fractions as an equivalent fractions with a common denominator, we look at the first fraction, and then we also look at the second fraction. We will take the denominator of the second fraction, multiplied by both the numerator and the denominator of the first fraction. And then we'll move on to the second fraction, and what we are going to do there is we are going to take the denominator of the first fraction and multiply it by both the numerator and the denominator of the second fraction. Now, how will that look like? How are we going to do that? We said 4 over 9, which is our fraction, our first fraction, we multiply it by the denominator of the first fraction. Now, the denominator of the second fraction is 8. So we multiply both the numerator and the denominator by 8, which is the denominator of the second fraction. Plus, we'll do the same for the second fraction. We multiply it by the denominator of the first fraction, which is 9. So we multiply the numerator by 9. We also multiply the denominator by 9. So I'll take that again. What I did here is I multiply both the denominator, the numerator and the denominator by the denominator of the second fraction. Now, when you go to the second fraction, what I did there was I multiplied both the denominator and the numerator by the denominator of the first fraction. This will give us what? 4 times 8 will give us 32 all over. 9 times 8 will give us 72 plus 5 times 9 will give us 45 all over. 8 times 9 will give us 72. So what do we have here? We have 32 over 72 plus 45 over 72. What can you observe from these fractions? We have now rewrite the previous fraction as an equivalent fraction with a common denominator. Now you can see that the denominators are the same. So we have 72 as a denominator for both the first fraction and the second fraction. This is what we were looking for, okay? Now, what is the next step now? Again, now it's very easy. We just have to refer back to our previous rule, which says if the denominators are the same, what do you do to the numerators? You just add the numerators. So what do? We have 32 plus 45, and that is going to give us 77 all over, we maintain one denominator, which is 72. We have 72. Okay, but if you can refer back to our note that was given to us, it is saying that we have to make sure our answer is written in its what? Simplest form. Okay? So we have 77 over 72. Do we have any number that can go into both 77 and 72 without any remainder? Do we have any? No. So what do we need to do here? It's very simple. 72 goes into itself, that's 1. Into 77 is 1 time. Remainder, 5 all over 72. So this is our answer. Okay? Okay, we have another question, and it reads 2 over 5 plus 1 over 4. 2 over 5 plus 1 over 4. So we have two fractions, and we are to add the two together. But what can you observe here? We can observe that the denominators are different. For the first fraction, the denominator is 5, and the second fraction, the denominator is 4. So in order for us to solve this, we need to do what? We need to rewrite the fraction as what? An equivalent fractions with a common denominator. So in order to do that, remember how we did it in the previous slide? We take the first fraction and multiply it by the denominator of the second fraction. And then when you come to the second fraction, we multiply this second fraction by the denominator of the first fraction. So now let's do that. It's going to be 2 over 5. So what do we do? Look at the second fraction. The denominator is 4. So we multiply both the numerator and the denominator by 4 plus, how about the second fraction? The second fraction, we have 1 over 4. And what are we going to do? We are going to multiply both the numerator and the denominator by the denominator of the first fraction. And that is 5. So we multiply by 5. We multiply by 5. So what do we have? 2 times 4 will give us 8. 5 times 4 will give us 20, plus 1 times 5 will give us 5, all over 4 times 5 will give us 20. So we have our two fractions, and what can we observe from the two fractions? We can see that the denominators are the same. Okay? Now that the denominators are the same, we go by our first rule, which says what? If the denominators are the same, you just add the numerators and you maintain one denominator. So what are we going to add? 8 plus 5 will give us what? 13 all over 'Since the denominators are the same, like I said earlier, we just maintain one denominator, and that is 20. So our answer is 13 over 20. Okay? Can we further simplify this? No. So our answer is 13 over 20. We move on. Okay. We have another problem, and it reads 5 over 7 plus 1 over 3. 5 over 7 plus 1 over 3. So we'll have 5 over 7 plus 1 over 3. Okay? Again, we can observe that our denominators are not the same. So we need to rewrite this fraction as an equivalent fractions with a common denominator. So what do? We know that the denominator for the first fraction is 7, and the denominator for the second fraction is 3. So we are going to multiply 3, which is the denominator of the second fraction, by the first fraction. And that is going to be 5 over 7. We multiply it by 3 That's the numerator, and also we multiply the denominator by 3. Then plus, our second fraction is 1 over 3, and we are going to multiply this fraction by what? The denominator of the first fraction, which is 7. So we multiply the numerator by 7, and also we do the same for the numerator. We multiply it by the denominator by 7. So what are we going to do from here? We multiply the numerators. 5 times 3 will give us 15 all over. 7 times 3 will give us 21 plus. We move on to the second fraction. The numerator we multiply. 1 times 7 will give us 7 all over. 3 times 7 will give us 21. So, what can we observe from here? We can observe that the denominators are the same, and this is exactly what we wanted, right? We want to make sure that we have a fraction with a common what? Fractions with a common denominator, and the common denominator is 21. So in the first fraction we have 15 over 21, and in the second fraction we have 7 over 21. So now we can go ahead and add, because the denominators are the same. So now we add the numerators. 15 plus 7 is going to give us 22 all over. We maintain one denominator, which is 21. Okay, remember we are asked to make sure that our answer is written in its what? Simplest form. Now, do we have any number that can divide both 21 and 22 without any remainder? Do we have any? No, we don't have. So what do we need to do here? We just have to say what? 21 goes into itself, 1. Into 22 is 1 time remainder 1 over 21. So that's our answer. That's one whole number, 1 over 21. Now let's go back to the options. A reads 1 whole number, 1 over 21. B, 1 whole number, 1 over 7. C, 3 over 5. And D, 2 over 7. So the right answer is A. Right? Is 1 whole number, 1 over 21. We move on. Okay, we have another problem. And it reads 1 over 2 plus 2 over 9 plus 1 over 3. I'll take it again. 1 over 2 plus 2 over 9 plus 1 over 3. Now we can observe that we have 3 fractions. And if you look at the previous slides, we were just dealing with 2 fractions. But now we have 3 fractions. And if you observe the denominators, they are all different. For the first fraction, the denominator is 2. The second fraction, the denominator is 9. And then the third fraction, the denominator is 3. So they are all different. So what do we need to do here? Again, we go back to the rules. It says what? For us to be able to add these fractions, we need to rewrite the fractions again as an equivalent fractions with a common denominator. Okay? So again, like we were doing for the 2 fractions, we'll do the same thing here. But the only thing is, for the first fraction, we are going to multiply it by the denominator of the second and the third fraction. When you come to the second fraction, what are we going to do? We are going to multiply the second fraction by the denominators of what? The first and the third fraction. And then when we move to the third fraction, we are going to multiply that fraction by the denominators of what? The first and the second fractions. I hope that is understood. I will take it again. For us to be able to make sure that we rewrite this fraction as an equivalent fraction, we are going to multiply the first fraction by the denominators of the second and the third fraction. For the second fraction, we will multiply the fraction by the denominators of the first and the third fraction. And then the third fraction, we are going to multiply it by the denominators of what? The first and the second fraction. Okay, we can start. The first fraction, we have 1 over 2. So we multiply it by the denominators of what? The first, the second, and the third fraction. And that is 9 times 3. Okay, we do the same for the denominator. We multiply it by 9 times 3 plus. We move on to the second fraction. We have 2 over 9. So what are we going to do? We multiply it by what? The denominators of what? The first and the third fraction. And that is 2 and 3. So we multiply it by 2 times 3. We do the same for the denominator. Multiply it by 2, multiply it by 3. Then we move on to the third fraction, which is 1 over 3. Again, we multiply this fraction by the denominators of what? The first and the second fraction, which is 2 and 9. So we multiply the numerator by 2 times 9. The denominator also 2 times 9. Good. Next, we do the multiplication. 1 times 9 will give us 9. And 9 times 3 will give us what? 9 times 3 will give us 27. All over. 2 times 9 is 18. 18 times 3 will give us 54. Plus. 2 times 2 will give us 4. 4 times 3 will give us 12. All over. 9 times 2 will give us 18. 18 times 3 will give us 54. Plus. 1 times 2 will give us 2. 2 times 9 will give us 18. All over. 3 times 2 is 6. 6 times 9 will give us 54. Okay? Okay, so what can we observe from these fractions? We have 27 over 54 plus 12 over 54 plus 18 over 54. So we can see that the denominators are the same for all the three fractions. Okay? The denominators are the same. So what do we need to do? We go by the first rule, which says if the denominators are the same, all you need to do is to add the numerators and you maintain one denominator. We have 27 plus 12 will give us 39, and 39 plus 18 will give us 57. All over, we maintain one denominator, which is 54. So we have 57 over 54. Can we think of a number that can divide both 57 and 54 without leaving a remainder? Do we have any number? Yes. 3 can go, right? So 3 into 54 is 18 times, into 57 is 19 times. So we have 19 all over 18, okay? Do we have any number again we can divide both 19 and 18 without leaving a remainder? No. So we can further simplify this as 18 goes 1 into 19 is 1 times remainder 1 over 18. So our answer is one whole number 1 over 18. We move on. Okay, we have another question similar to the previous one. We have 1 over 7 plus 2 over 5 plus 1 over 2. I'll take it again. 1 over 7 plus 2 over 5 plus 1 over 2. So we have 3 fractions and we are to add these 3 fractions together. So what we need to do, going by the rule, we multiply what? The first fraction by the denominators of the second and the third fraction. So we'll have 1 over 7 times 5 times 2. We do the same for the denominator. We multiply it by 5 times 2. Plus, we move on to the second fraction, which is 2 over 5. We multiply this fraction by the denominators of the first and the third fraction. And there, you multiply it by 7, you multiply it by 2, and we do the same for the denominator. We multiply it by 7, we multiply it by 2. Plus, the third fraction is 1 over 2. Again, we multiply this fraction by the denominators of the first and the second fraction, which is 7 and 5. So we multiply it by 7, multiply it by 5, the same, 7, and multiply it by 5. So we now multiply. 1 times 5 will give us 5. 5 times 2 is 10. All over. We have 7 times 5 is what? 7 times 5 is going to give us 35. 35 times 2 will give us 70. Plus 2 times 7 will give us 14. 14 times 2 will give us 28. All over. 5 times 7 is 35. 35 times 2 will give us 70. Plus 1 times 7 will give us 7. 7 times 5 will give us 30. 35. All over. 2 times 7 is 14. 14 times 5 will give us 70. Okay. Now what can we observe from these fractions? We can see that the denominators are the same. Okay, and this is exactly what we wanted. Since the denominators are the same, what do we do to the numerators? We just add them, right? So we add 10 plus 28 is going to give us 38, and 38 plus 35 is going to give us 73. All over, we maintain one denominator because the denominators are the same. We have 70. Okay? Do we have any number that can divide both 73 and 70 without any remainder? Do we have any? No. So what do we do? 70 goes 1 into 73 is 1 times. Remainder 3 over 70. So this is the answer. We have one whole number, 3 over 70. Okay? Okay. That brings us to the end of this lesson, but before I go, I'll leave you with some questions to try. And question 1 reads, 3 over 8 plus 1 over 5. I'll take it again. Question 1 reads, 3 over 8 plus 1 over 5. Question 2 reads, 3 over 6 plus 4 over 7 plus 2 over 4. I'll repeat. Question 2 reads, 3 over 6 plus 4 over 7 plus 2 over 4. Now try this, and then when we meet again, we'll try to do the correction. In the meantime, thank you so much for following the program. That's the lessons. Thank you.